Hello, my name is Alessandro Loia. I am the founder of Thrive Software LLC and have been developing a web app called DNALocker over the past few months as part of the independent study in computer science class at the Liberal Arts and Science Academy High School in Austin, Texas. I've been working on an idea for the past 2 years that incorporates my interests in computer science, more specifically and recently decentralized computing, which includes cryptocurrency and blockchain technologies, with biotechnology and bioinformatics to be specific. Bioinformatics is the analysis and/or digitalization of biological data including, but not limited to, DNA and protein sequences. Last year, after having my DNA sequenced by 23andMe, a personal genetics and bioinformatics company that identifies the differences between individual genomes and that of the Human Genome Project in an attempt to pinpoint genetic links to our expressed attributes, I noticed that I could download my raw genetic data from the service. I had to ask myself if 23andMe, Google, or Amazon Web Services servers were really the safest place for such sensitive information that could, in the hands of insurance companies or the government, lead to adverse effects to individuals or their next of kin. Having dabbled in Ethereum, I devised an idea to anonymously store this data on the blockchain. However, it was clear that this was not the solution, as the blockchain is designed to publicly and immutably store records, not contain several megabytes worth of text in some transaction. With further research, I discovered that Ethereum, in its effort to create a new, decentralized web, or what they call Web 3, offered a service called Swarm, a decentralized storage platform. I quickly realized that Swarm was far from being ready for such sensitive data, so I kept looking for a suitable platform and found Interplanetary File System, which has matured to a point that I am comfortable working with. As such, I began work on an app to encrypt, upload, decrypt, and download from this decentralized storage platform. The backbone of the app that I set out to construct in the last semester needed several key requirements. As such, I should be able to answer the following questions from users. Number 1. How does DNALocker help me safely store my genome data file? DNALocker is a service that makes it easy for you to encrypt your genome file using extremely strong AES encryption and store it on a decentralized storage platform, or DSP. We call DSP a DNALocker because it's a much friendlier, non-techie name. The DNALocker ID you receive is in fact the DSP address mapped directly to your file. Since you are the only human being to have the DNALocker ID for your encrypted file, it is completely anonymous on the decentralized storage platform. Since only you have the passkey needed to decrypt your file, the encrypted data is completely secure. You, or anyone you share your DNALocker ID and passkey with, can quote-unquote open the DNALocker at any time in the future and retrieve your original genome file. Anonymity is also a central benefit to keeping your data secure. Who you share your DNALocker ID and passkey with is your secret. Third, DNALocker uses AES 256 encryption since it is trusted by the US government for its classified files as well as throughout the industry. Finally, the nature of storing data on a decentralized platform is just that. It's not stuck in any one place, like at a single provider, a safe, a hard drive, or a USB stick, all of which can be penetrated or destroyed. Number 2. Once I've stored my genome data in a DNA locker, how do I open my DNA locker to retrieve the genome data file? To retrieve the data in a DNA locker, you will need your DNALocker ID, which is the same as the decentralized storage platform address, and the passkey you used to perform the original encryption in order to decrypt the genome file. You may use the DNALocker service as well to help you easily find and decrypt your genome data file. However, one of the nice features of the DNALocker is that you are not dependent on the service. With a little technical knowledge of the decentralized storage platforms we use, Interplanetary File System or Ethereum Swarm, you can find your encrypted data using your DNALocker ID, so do not share your DNALocker ID with anyone you do not trust. Likewise, with a little knowledge of how AES encryption works, you can use your passkey to decrypt your encrypted data, so do not share your passkey with anyone you do not trust. We think this is a great feature since the person you might want to open the locker may be a loved one or offspring many years in the distant future. At that future time, all they will need is the DNALocker ID and the passkey that you have made available to them to access your genome file. Number 3. Does DNALocker store any of my personally identifiable data? No. DNALocker stores no personally identifiable data about you. Much like a cryptocurrency wallet app, it maintains your anonymity throughout the process. DNALocker is a service that makes it easy for you to encrypt and store your data in a decentralized storage platform. But the service itself stores nothing that identifies you. Once your genome data file is encrypted using your passkey and uploaded to your DNALocker on the decentralized storage platform, and you have received the DNALocker ID, any temporary data used by the DNALocker service to complete the operation is immediately deleted. DNALocker IDs are addresses on the decentralized storage platforms, just like a Bitcoin wallet address is public on the Bitcoin blockchain. But in both cases, the identity of the owner of a blockchain address remains anonymous. Your payment information, for instance credit card information, is also not stored by DNALocker. Number 4. How do I get a copy of my genome data file? First, get your DNA sequenced. This can be done for a fee by a variety of services like 23andme.com, Ancestry.com, and many others. Whichever you choose, read their service descriptions carefully to ensure that the DNA sequencing service you purchase gives you access to your DNA raw data file. This raw data file provided to you by a DNA sequencing service, usually in a .txt or .csv format, is what we refer to as your genome data file. Some DNA sequencing services give you the option to request that your raw data file be deleted once they provide you with their reports. It's a good idea to request your raw data file be deleted from the DNA sequencer storage after you have downloaded a copy for your own safekeeping or you have uploaded to the decentralized storage platform through DNALocker. Number 5. What happens if I lose my DNALocker ID or passkey? Nothing happens. Your genome data file is anonymously and safely encrypted, stored exactly where you left it on the decentralized storage platform, possibly till the end of humanity. We recommend keeping your DNALocker ID and passkey in a safe place that you normally use to store important family records, such as a safety deposit box at a bank, and let trusted loved ones and executors know you have stored your genetic information in the event it is needed in the future. DNALocker does not keep any personally identifiable records, so if you lose your DNALocker ID and or your passkey, we cannot quote-unquote recover it since we do not store any of your information. Number 6. Can I quote-unquote open my DNALocker more than once? Yes, Your DNALocker is persistent. It lives on the decentralized storage platform, presumably forever. This means that it can be quote-unquote opened as often as wished using the DNALocker ID and passkey to access the decrypted version of your genome data file. Many decades into the future, if your offspring, some of whom you may never meet, need to access your genome data file, they can access it using your DNALocker ID and passkey. The DNALocker service can be used to quote-unquote open it, or by obtaining a little technical knowledge of our decentralized storage platforms, such as Interplanetary File System or Ethereum Swarm, and the AES 256 CBC cipher. Number 7. Can I use my passkey for different DNA lockers? Yes, your passkey strategy is your own. You choose the passkey, which must be 32 characters or longer as required by the AES 256 cipher, and use it to encrypt a genome data file each time you use the DNALocker service to upload a file. So, you can use the same passkey to encrypt multiple genome data files into multiple DNA lockers. While this may make it easier for you to remember, store, transfer, or type passkeys, it also presents a risk if the passkey is stolen, as more than one DNA locker will be exposed. However, if the perpetrator does not have access to your DNALocker ID, they will not be able to access your DNALocker. Number 8. What is your privacy policy? DNALocker believes your genetic data is the most private and confidential information that exists about you, as it defines who you are. So we go to great lengths to design our service in such a way that your anonymity and confidentiality are protected. We do not store your name, payment information, DNALocker ID, passkey, or genome file. We will never sell your information because we have no information to sell in the first place. Number 9. Why did you choose AES for data encryption? Are there more modern algorithms to choose from? AES 256 is the strongest of the ubiquitously used and thoroughly analyzed family of algorithms considered universally to be very secure. AES is a U.S. federal government standard and is approved by the National Security Agency, NSA, for top secret information. It is prevalent in its use across the globe by governments, militaries, corporations, cryptographers, and private citizens. It is so widely adopted because a brute force attack requires computers that do not yet exist to run for trillions upon trillions of years, consuming more energy than the human race is capable of producing, and making all classes of computational attacks probabilistically impossible for the foreseeable centuries to come. While no one can predict what technological advances the future will bring, such as quantum computing, cryptographers for the world's governments, corporations, and militaries are sleeping soundly with their choice of AES. There is broad agreement among security experts that the easiest means to crack strong encryption is to either steal the passkey or to guess a passkey that was conjured up using popular and more easily guessable passphrases. We recommend choosing an unusual passphrase that uses lowercase, uppercase, symbols, and randomization that only makes sense to you for your DNALocker. There are more obscure encryption methodologies we could have used, but we think ubiquity is also a great feature of AES, since there are literally thousands of technologically inclined people who know how to use AES and ample documentation to learn about it. This means that far into the future, whomever you wish to quote-unquote open your DNALocker will very likely be able to easily find skilled professionals to perform the decryption if they can't do it themselves. Number 10. What about your website? Can't it be hacked? 1024-bit RSA SSL encryption protects your data from electronic and physical attacks while transmitting to and from our site. We do not store your data in any way other than placing it on a decentralized storage platform. After your data is encrypted using your passphrase and placed anonymously on the decentralized storage platform, you will receive your file's address as a DNALocker ID, and we delete any trace of your files. Your encrypted DNA data remains confidential, anonymous, and secure. Our backend services rely on both Amazon Web Services and Google Cloud, which are the leading, most secure platforms for applications such as DNALocker. Several computer science principles were heavily utilized, learned, and relearned in the making of DNALocker as it combined encryption, distributed computing, and web application methodologies into a cohesive experience. The front end relied on HTML5 and JavaScript for ensuring delivery of files to and from the backend, including streaming large files to the backend due to limitations on how much data can be sent in a single post request. The backend was written in Node.js and utilized libraries for the AES cryptography, interfacing with interplanetary file system, and sending email to users. Procedural and object-oriented programming principles were used in this section of the app. Asynchronously executing functions were also utilized as part of the Node.js portion of the application. The genome file itself was manipulated in preparation for encryption and decryption while including the initialization vector required by AES CBC. Over the last few months, the following tasks were completed in the pursuit of building DNALocker. Each required referencing undergrad catalogs and the aforementioned computer science principles for completion and were verified to comply with SMART guidelines. The completed tasks are file encryption, file decryption, functional user-facing web interface, being able to encrypt and upload to the backend, functional file upload to the decentralized storage platform, functional file download from the decentralized storage platform, functional user-initiated upload from the web interface, functional user-initiated download from the web interface, as well as functional notification to the user of their DNALocker ID for future access to their files through email. SMART guidelines require that I was able to complete each of these tasks in the 2 to 4 week sprints that were allotted. Speaking of undergraduate catalogs, throughout this project, I referenced the University of Texas at Austin's computer science offerings to guide my project in each layer of interaction with the user and between systems like the front end, the back end, and the decentralized storage platform. I also referenced the Massachusetts Institute of Technology's literature from their decentralized currency initiative to define my goals in terms of using distributed computing to create a viable, useful product. Furthermore, I took a look at Stanford's Introduction to Cryptography class for some guidance in safely and effectively using cryptographic techniques to encrypt and decrypt the provided genetic files. Now I will walk through a short demo of some of the functionality of the app as it is. Keep in mind it is not fully completed and that I will continue to work on it next semester. Hello and welcome to the first demonstration where I will be showing you how the application can encrypt and decrypt files that are uploaded. So firstly, I will show you, so right now you can see that I have selected this file right here, genome mycolage hybrid shortened.txt, and you can see that this file right here. So this is a genomic file that's listing the differences in the chromosomes depending on their position. And this is a shortened version because the development environment cannot handle the full size of the file, but in a real server environment, there wouldn't be no problem with being able to send a larger file over a post request because the largest they get is 30 megabytes. This is about 14 kilobytes. So I'll go ahead and use this key right here, which is 6 hellos in a row. Definitely not recommended for real use, but it will suffice for this demonstration. So as you can see, it has downloaded an encrypted text file. Let me open that in Chrome. So as you can see, it is a base 64 encoded encrypted file of this file right here. So now what we'll do is demonstrate the decryption ability of this rudimentary form. It's not pretty to look at, but it works. So let me open the newly encrypted file, insert the same 6 hellos in a row as the key, and voila, we have a decrypted downloaded file, which I'll open for you. So as you can see, it is identical to the original. If we put them side by side, you cannot tell the difference between them besides the URL. So that demonstrates how this portion of the app is able to encrypt and decrypt. Thank you. Welcome to the second demonstration. So as you can see, now the URL has changed to upload. So I'll show you here in the Cloud Shell code that I've written up. You can see that there has been added to this a constant called IPFS, which requires a package called IPFS. So that's Interplanetary File System. So we're ready now to start uploading to the decentralized storage platform. And that's what's happening right here in this asynchronous function. So let's go ahead and get started. I'm going to go ahead and choose the same exact file that I chose before, genome mycolage hybrid shortened.txt. So this is what you see right here. Go ahead and do the same 6 hellos. Alright, so that returns, so what I did is in the HTML template, I left a little placeholder for the ID to be returned to me. So I'm going to go ahead and copy that to my clipboard and navigate to the download page. Go ahead and paste that in. Do the same 6 hellos and we have a download. Let me go ahead and open that in Chrome. So as you can see, these two files are identical in all but path. This just came from the decentralized storage platform. So as you could see, this is not the most beautiful user interface ever devised. So next semester, I'll definitely be working more with the user experience and user interface and making sure that this is more of a viable product and actually able to be used by someone who doesn't understand what would happen, what this is, and of course there would be more documentation written for them and other things that are required of a public-facing product. But I'm very excited with how this turned out, and I look forward to working further in the independent study course at LASA High School in the next semester. So this has been my reflective presentation for the fall semester of independent study computer science at the Liberal Arts and Science Academy High School. And thank you for watching.